This should be the last part that I'm putting on the lathe this year. Hey, what's up everybody? Welcome back to the shop. So this is the piece for my that's going to lead from the cross slide to the taper attachment. You know, obviously, I guess. Maybe not so obviously. To make it fit, I got to do some stuff that I wasn't really intending on doing, but it's actually got a little more in-depth and complicated than I thought. So first of all, hollow out to a depth of 0.345. So everything in here has got to get hollowed out, and that's just to make room for the dovetails on the lathe. Mill slot. Yeah, obviously, that's for the bolt that attaches to the taper attachment. Then we got to mill this out, leaving a 1/4 inch at the base. Just this square portion here. Yeah, and that's about it, I guess. Eventually, we're going to have to hook this up to the rotary table as well, so we can get a nice radius around here. What I want to do is I want to leave a 1/4 inch web all the way around to add stiffness to this. So then once we get that all done with, we got to flip this over and flip this over. And I was going to deck 167th thou off there, but had a change of heart. I'm only going to deck about 1/8 of an inch off there. I also made some different thoughts on this too, because this will be up on the rotary table. And when I'm doing this radius, I'm going to do a ball nose radius on this side. And that's mostly just aesthetic, but it would actually be beneficial as well, because it'll leave a little more meat over here to stiffen things up a bit. And then what else? So you got drill and countersink 2 holes. That'll be just for beveled head screws. Okay, I guess that's it for step 2. I'm going through this all with you now because I'm just going to get lost. Yeah, eventually this just I'll saw this off. I'm not going to mill all that off. This is rotary table, and then scrap part. No. And also this radius will allow for a little bit more room. That's where the taper attachment nut's going to go. So yeah, I went to 125 because I only have a 1/4 inch ball nosed end mill. If I had a 3/8 or so, or 1/2 inch even, I'd probably go a little bit deeper. But anyways, I'm going to chuck this up in the mill. I got the swivel vise on there, and we're going to get started on this, I guess. Okay, so we got an end mill and some material. Let's make some chips. Hey, this is where it's going to get a little chaotic here. Almost certainly. I'm going to start by milling out this little rectangle here first before I rotate the vise. Now that I got the numbers locked in, it shouldn't be too bad. Just remembering to turn which dial in which direction at this point. Okay, that's pretty much the gist of that part right there. I'll bring you back when I swivel the vise and start doing the angles. But yeah, I'm basically just going to trace that out, just leaving just enough that I can go on the other side and cut that off and whatnot. But I got to leave this on here until I got to leave this all together until I'm ready. Okay, get back to you in a bit. Alright guys, well there's our little pocket. It actually turned out really nice. Can't complain about that, but that's basically what that's all going to be through there. So thankfully the vise markings down on the bottom here are at least as accurate as my little protractor or whatever. So now I'm just going to kind of fumble around to find a starting point, and I'll make note of where the numbers are on the DRO, and I'm going to keep going straight down until I go to depth, all the way to the just to get the angle cleared up, and then I'll probably straighten it all out again just so I can hog out some more of that stuff. But yeah, I don't know, I'm just winging it here, so all right, so here goes nothing. Alright, let's see how it looks. It's this thing's going to be considerably lighter, I think, by the time this is done. This actually would have been a good casting project if a guy had the means to cast stuff. There, satisfied? I know I am. The little dinky cuts get tiresome after a while. I left a little bit on the bottom so I didn't have to, just in case. In case I pulled the end mill out. That end mill's pretty dull, I think. But if you push it, she'll still hog metal out. Anywho, that's about, well, that's more or less all I can really do on this side now. I think I'm going to leave that slot for the other side. That way I'm preserving some of the strength, for the other operations. So, yeah, I'm just going to tidy up here and then flip it over, deck off the top, and mill a slot. Oh. Well, unfortunately, I don't have any bevel head hex screws. Well, I got this one. It's a metric screw, but it's pretty close to the same size. So I'm just gonna have to kind of guesstimate for that, I suppose. Alright, that's about right. I don't want to break that edge. That's sitting a little lower, so that should be good. Well, guys, I think I'm going to opt to do that slot after all, before I take it over to the saw. Just because when I go to put it on the rotary table, I'm going to need that slot for clamping purposes, I think. And I went ahead, I reamed that to, well, it doesn't matter. I reamed that to half an inch, but I'm still going to have to, I'm going to bring out both ways, 43 thousandths or something like that, just so it doesn't look off to one side. I gotta speed that up. That's way too slow. Hey guys, okay, so I don't know how you guys do this. You can take the indicator and you can indicate this out. What I've done is I've made an MT2 sleeve or whatever, or a plug, and inside the plug has a reamed 1/4 inch hole, and that's for a 1/4 inch dowel pin. So I take the dowel and I stick it into the collet and tighten up said collet, and I just kind of keep plugging away at this until it actually goes in. And once you get it in there, it does work. It's really tight, right? Oh, there we go, right there. Boom. So now you got that in there. You zero off your X and your Y, and that's it. And now every time you got to come back to this, you know exactly where it is. You can save that in the SDM function or something like that, and it's perfect every time. Anywho, I got the saw set up again. Got some lines drawn out. This will be a little bit easier, hopefully, than it was the last time cutting this out. If you remember, it was this whole thing like that. So this shouldn't be too terrible. So I'll get this cut, and I'll meet you back up on the mill. Sorry, guys. Not very much action on this. I know I hogged it out pretty good, but I don't want to hit the high spot back here. I don't know where it's at. There it is. Okay. Now I know where the high spot is, at least. And we should be able to start following the numbers now. I repositioned it a little better. I couldn't live with that. That was like shit. So hopefully taking a little more meat off now for sure. That looks way better. Way better. Okay. I'm happier with that. That was looking pretty rough. Okay, let's bring it down and take a quick peek here. Just so you guys know I'm not completely full of shit. Okay, let's take a quick look at that. You can kind of see it from there. It looks better. We're down some more even. Yeah, at least we got both sides all the way around for the most part. Except for that little bit right there. I went a little too far when I was hogging it out, I guess. Anyhow, guess I'll flip it over and put on the finishing touches now. Alright, folks. So apparently I got to do 15 things stupid before I do them smart. I ended up making a plug that fits in the center here to keep it in line, and then I did the dial indicator and everything to make sure it's all running straight and on 0 degrees. So yeah, now it's just a matter of, I guess, rotating this 10 degrees and then slowly bring it into dimension. Kind of dealing with a saw cut. So I'm going to have to take off that high corner first before I can do the whole length. And I'm just going to get it just... Oh, you know what I should have done? That's going to hit right there big time, yeah. I just want to see where the aluminum is before I want to see this too. Well, it's been a huge caffeine-fueled adventure, but I think I finally got this thing going pretty darn good. I had to fabric cobble that little thing up right over here because the one that came with it totally didn't work. It was dragging and meshing it really hard against the top gears, and it did not move very smoothly at all. So yeah, she was my first machining project. I did it all with the cross slide and the top slide, and I guess a and I guess the whatchamacallit, the end thingy. The end stock, or whatever. Head stock. Whatever. End stock. Anyways. So yeah, I got her working pretty good. That's my... It actually machines good now. And I do got the power feed somewhat working, unfortunately. It's in kind of high gear. And it does a pretty rough, shitty looking cut. But until I get the last piece that I need for that gear, it's gonna have to do, and I'll just have to hand feed everything. But she's a beautiful old girl. She's a 1936 Atlas D. I'm not sure what that means. 10D 28 inch bed, I guess. So yeah, she's actually not a bad machine. She's heavy. She ain't no lightweight. For they built them tough back then. Anyways, back to my machining adventures. Stay tuned. Alright guys, so actually, damn, you know, I know this is I'm gonna jinx myself because my mic's already died, but this is actually working out pretty good. The table is functioning really nice. I tightened it up in the crank area from last time I used it. Well, not the last time, well, quite a while back when I was doing the taper attachment. This thing was springing around really bad. But now I'm giving it pretty decent cuts, and it's not grumbling at all. So I'm quite happy with this rotary table now, suddenly. Okay, so I got like 2 more passes. Well, 2 around the curve anyway. And this should be the last one around the curve anyway. Should be 170. Yeah, okay. Actually, he's not too bad, I guess. Should be able to blend the rest in, I hope. I have to back this off a bit, though, so I find the high spots. Close cut with that saw, holy cow. Too close. Well, that should be it. That was really close call right over here. Just one little spot didn't quite clean up. But you know what? I think that kind of might just add to its character to make it look more like a casting. Okay, so we got, damn, what else? Got one more little thing to do on the back end here. And just let me swap end mills here real quick. Alright guys, so this is basically just an aesthetic feature. Just gonna keep spinning it back and forth till I get a nice arc in there and it takes up these corners and then we're done. More or less. Might actually take a little while. Yeah, there's a touch off. So I think this is going to take a while, guys. I got to make enough clearance for that knob yet. So got another. I can only go so much. It's rattling pretty good. So we'll have to get back to you on this. All right, guys. So there's our illustrious bracket, all milled out. It's almost. It's close to perfect, I guess. Could have went a little further on this side. It's a little different, and it's also a little different here. So obviously I could have went a little bit more on this side, but. I'm not too worried about it. Like, it is going to 100% serve its purpose. I just wanted you guys to see it before I actually had to hog that out to make for the end of the taper attachment. You'll see it in a minute. If I ever do anything like this again in the future, I think what I would like to do is make this pin, but also make a key instead of just bolts or whatever, because this was not the same size as 1/2 inch, so it needed a proper pin in there. But if I had a key in there, then I could have been able to just flip it over and it would have been perfect both ways, so it wouldn't have mattered. But as it started out, I didn't really I just kind of eyeballed it there last time without the pin, and so that's probably why I got a little bit of error there to start off with. So no big deal. I gave it a little bit of a swipe with Scotch-Brite and dulled the corners off of it a little bit. There's a little radius that I was telling you about, or that I started on last. I went ahead and modified my cross slide off camera. I just milled that pocket in there, and then this will just drop right on here. And these aren't the right screws. I had actually, I want the beveled headed screws for this, obviously. But these will work for now. And it's a very nice fit. Very nice. You can kind of feel a bit of the transition there, but for the most part, it's really good. Like it's kind of hard to get the whole thing in one shot here. But that's basically it right there. It's a far cry from the original Atlas one, that's for sure. There's one more little thing I'd like to do to this. It's mostly aesthetic. I'm just going to hit these dovetails again. Just bring that out so that it tapers off a little bit like that within this bracket. Just so it doesn't look like it's, I don't know, blend it in a little bit better. Just right to the corner and call that a day. So other than that, the little dovetail, and I gotta hog this little spot out. I might just do that off camera, and I'll meet you at the lathe when we'll take it for a test drive. Well, all right, guys. Smoke them if you got them. Hopefully this reassembly goes smoothly on this one. Usually there's some kind of thing I overlooked or something, but we'll see. I don't think so. I think I got it this time. Knock on wood. Nice. I think we got it this time. It's gonna need some oil though. She's pretty dry. Where's the knob? Oh, here it is. I was really worried about that. That's a pretty close fit. I think that's pretty good right there. So, okay, my whole point of this is this part right here. You can see the cross slide. It's got this in there. And that's just from that nut. Like, that nut is in pretty bad shape. So the point of this being is, as this is pushing out, it's pushing this back. But also the tool pressure is pushing this back, so it's got to stay against the back of the lead screw on this side of the thread. If it just runs willy-nilly and this doesn't push this cross slide back as it's turning, it'll jump back and leave steps in there. So that's the whole point. So when this is back here, you lock that in, and then that's rigid. And that's basically the whole reasoning behind that. So I guess we'll, without further ado, let's waste this chunk of metal and give it a try. We are basically wasting it, sad to say. Ooh. Okay. Oh, I'll do 30 thou right off the hop. This is messing around. It's kind of slow. We can speed it up if this thing was working out okay. Know that. Tighten this up. Gauge lead screw, and that's Bob's your uncle. Okay, according to my cheat sheet, that's 266 RPM. The next step up is 416, 418. I got this off the internet. A little easier. I don't have an RPM gauge, so that's just a little easier to deal with. And according to speeds and feeds, who's it? High speed steel and mild steel. I'm going to calculate that. I think they said, what is it? 90 times 4, something like that. And divided by the size of the stock equals 480. So yeah, we could definitely step it up one notch. And surface finish is actually quite respectable. Yeah, that's a little more. Not gonna smoke like hell though, but that's okay. Loosen that off. Another 30. Making another pointy thing. Well, I guess maybe we can give you a show and show you what happens when I don't lock this button back here. I'm just going to only give it a little cut though, because it's going to dig in. It's 5 thou. It's going to do some not so pleasant stuff. Probably. You can see how nice the finish is, nice and straight up here. Now it's basically cutting straight right now. I can see it getting deeper and deeper. That's only a 5 thou cut, so obviously something's wrong. And it'll jump out eventually here. Just scared to let it do it on its own. Yeah, see, it's terrible now. The big straight spot right there. It'll be all, now it's turning straight again. Now that it's caught up to the grip of the whole cross slide, now it's just going to keep doing that big mess. You got to basically hold it back. See, look how much slack that took up. There's 5/0 cut right there. A big mess if you don't tighten that up. Not cool. So our bracket works. I think I'm just going to leave it at that. I'm not really making anything. I'm just wasting material, which I don't have. So yeah, made a big freaking mess there. And I kind of want to clean that up now. If I can. Yeah, what is that? 10 more thou, and I think we're gonna run into it. Oops. Yeah, you saw it here first, kids. Lock that down. Another buck. Hopefully it cleans up all that mess. I think there's basically a bracket like that on most taper attachments. Maybe not on a big Monarch or something, but I know they're on South Bends for sure. And the big lathe we had to work, I believe, had a lockdown pin too. It does appear to be cleaning that up. A little bit of oil just to help her along. Yeah, so we're going to do a quick finish cut here. An actual 5/0 cut. Hopefully it works out. Okay, I have to admit that was kind of fun. And that is actually a really good finish for high-speed steel. That is very smooth. You can't. That's really good. All right, folks, that's the whole taper attachment / cross slide modification done. I gotta call that a wrap, I guess. So yet another strange part with some different angles and stuff going on there. I could have done a better job, but it is what it is. I'm not gonna... What's the word? Fussiness is the enemy of progress. So I guess we're just gonna have to live with that. Huh? It's still pretty good. You can't see anything from the highway. Anyways, folks, hope you enjoyed all that. I got lots of projects planned for 2025. I hope you guys stick around. Thanks for watching. Peace out. No, shit, sorry guys. Got a fucking arm in the way. Fuck! Get the fuck out of the way. Hey, I think that's better.